In the big Bilge Tank, we'll keep you in the know. In the big Bilge Tank, we'll fix your techie woes, and we'll break things and we'll make things till we're all together raking, and we'll raise a cup of grog down in the big Bilge Tank. In the big Bilge Tank, come and join our pirate crew. In the big Bilge Tank, we will show you what to do. And we'll hack it till we crack it, and we'll tell the world about it and forget to tidy up. That's why it's now a Bilge Tank.
Right, now we should have sound.
Hi, I was getting into the miming there.
Yeah, cool.
Oh,
Hi and welcome to Bilge Tank 078, where we have two of the folks from the very widely distributed Resin.io team. It's Carlo and Gege.
Hello everybody.
Yeah.
Oh,
Cool. And you are based in London and Milan.
Yes.
Yeah. So tell us a little bit about Resin.
Alright, so at Resin we managed to allow users to develop, deploy and manage Docker Linux container applications on embedded devices.
Yeah.
So this basically goes from the prototyping phase to the actual deployment and across the whole life cycle.
Yep.
Of course, it's useful from for scenarios that goes from maker prototypes to large enterprise applications.
So we're talking like one device to thousands.
Yeah.
Yeah.
Okay.
Tens of thousands.
It's all about being able to scale the solution without having to figure it out on your own.
Yeah.
okay. 5 exclamation marks. Popular.
Yeah. Cool.
Yeah.
Tuck in a bit, Phil. You're getting cut there, man.
Cool.
We've got to get cozy here. Yeah.
Yeah.
So what you have is you have devices like the Pi
Yeah.
or other Linux platforms which
Yeah.
have your kind of software on an SD card,
Yeah.
whatever, hard drive. Yep.
Yeah.
Then you have things like Docker, which you use to kind of package things.
Yep.
And then you're like the top layer that has a thing on the internet that will say, take this container here, put it on that device over there, or those 500 devices over
Yeah.
there.
Exactly.
Cool. There are other reasons. If you're into Raspberry Pi, you might have heard of the Resin folks. I'm just going to see if I can get this up on
I think
screen.
at least one person.
Hey,
has.
so there's the Resin website. That tells you all the kind of boring stuff about taking care of your whole enterprise.
Yeah.
It's really nice. Yeah. Nice.
Yeah.
Yeah.
Yeah, we actually support more than 20 different embedded devices.
Okay.
And,
Yep.
So what we do is basically maintaining Resin OS, which by the way is an open source project you can use to do the local development, and then you can scale up all the management features on Resin.io.
Yeah, because your big boss guy is Alexandros.
Yeah, exactly.
Yeah, he's big on security and open source and kind of making sure these things are bulletproof.
Yeah, I mean, security is something that you need to keep iterating. It's definitely something that is elastic and in continuous development. And of course, we really care about it.
Yeah. No matter which IoT meetup you go to, there's going to be at least a dozen people come to you. But is it secure? And, whatever that means.
Question actually to.
Yeah, there you go. Etcher and
It was a kitchen company. I can't remember which one it was. They made appliances and said, "But are they secure? Your IoT appliances?" And they gave the very, very satisfying answer. Actually, it basically amounted to, "Yes, we've tested this stuff for 10 years. It's secure. We know what we're doing.
Yeah.
Calm down."
So you might also know Resin for Etcher. Les has mentioned it on the chat. It's just an easier way to burn cards.
Yeah.
Yeah.
So
Across platforms as well. So it's like
yeah,
we've got like Windows, Mac, and Linux.
Yeah.
Same interface. Take an ISO, take a DMG, take whatever kind of zipped images.
Yeah, you can also feed the archive and compress the
Hey,
images.
so I don't need to unzip my
No.
noobs anymore.
Not at all.
I just downloaded noobs and I just unzipped it and I realised I did not have to do that.
Yeah.
Yeah.
You
Given-
can
I
use it.
didn't realise that.
Yeah.
I
Yeah.
unzipped it.
Cool.
Wasted valuable time.
Yeah, so we've got noobs there.
It's become my officially recommended burner now. Having finally used it.
Cheers.
Yeah. So gzipped or other thing that you like, and basically the idea was around it that you're writing so much documentation. Why do you have to write 3 times if you have Windows? You do this. If you have Linux, you do use that.
I used the noobs there and it didn't work. It failed. It says I need to have 1 image in the zip.
Ah,
yeah.
Okay.
I need to download Raspbian, don't I?
The Raspbian works.
Yeah,
Resin OS.
Noobs is
You have an OS?
a zip you extract to the SD card, isn't it?
Cool.
Yeah.
Okay, so I need to go back to the Resin
You could do that as well. If it didn't find an image in the zip file, it could just go, format the SD card to FAT32 and extract the contents of the zip file.
Cool.
Could try.
We perform validation on both what you feed and what you write on the SD card to prevent this kind of things, like writing that zip file as the actual image.
Yeah, it happens, and it's not an unreasonable thing to do. You know,
Yeah.
you don't need to necessarily know about this stuff. It's something we all take for granted, but people will not have that knowledge because it's not passed along unless you need to use it. So having you do the smart thing, great. That's less friction.
Yeah.
Superb.
So kudos to Quanchi, the maintainer, and it's all about a very clean user experience. We're still working hard to simplify even more and extending functionalities. But yeah, that's the goal.
Yeah.
Cool. So I'm downloading Resin, but you've already got something. You're going to take us through the kind of the life cycle of deploying this to something, aren't you?
Yeah.
Okay, so take it away.
All right. So I'll use this Pipe Zero with a very cool speaker FAT. So I'm gonna go right in the SD card. So we are gonna have a fresh device provisioning.
Yep. Do you need an SD card?
Yeah.
USB thing?
Yeah.
Okay, I'm just gonna...
No, I have in my backpack, I just need to go grab it.
You just need to slip below the monitors there as if you're disappearing.
Okay, I can mimic
Yeah.
Saw nothing!
No, there's nothing to see here, absolutely.
Cool.
There's a lot to see here. In the meantime, we can chat about.
So here's some of the devices. We've got the speaker hat you're going to deploy to. You've also got. This is the reason why I was kind of excited about you coming here.
So while he's away, I can tell you that he's come back. He's sort of our master maker inside the company. I have said nothing good about you.
Okay, great.
So
as always, then.
He's doing a lot of work around hardware, interesting new things, and
because you do the Google thing, don't you? You have the Friday kind of
Friday
related
hacks.
but independent projects.
Yeah. So every Friday, people in the company can work on their own projects. Something resin related, but not your normal work, and it can be connected speakers like this one, or trying out new technologies, or making a different Pimoroni hat working. For example, which takes up a lot of different Fridays. So
I've switched to your laptop here, and you've got the dashboard, and in front of it you've got Etcher running.
Yeah, so I'll first walk you through the flashing part, which is really easy. So I'll just have to pick an image like the Boombastic.
That's just an IMG file, which is straight bits.
Just to be sure that I pick the right one.
Cool.
So Etcher detected my removable media, so I can just hit flash. It escalates privilege because we are actually writing stuff on a device. And
it's made sure it's not the hard drive.
Exactly.
Yes.
So what happens now is that I'm writing on the SD card, and then Etcher will perform validation. Going back and reading the SD card after writing to be sure that everything went successfully.
It takes a little bit of time, but when you're doing this,
if
you're
you're a beginner doing this, I definitely notice some people have bad flashes for their SD cards, and will try and bootfire with a bad flash SD card.
This helps you detect the issue before getting mad on and trying to understand what's happening on your device.
It takes a bit of extra time, but that preemptive issue detecting is way
99%
of putting it in your car pie and going, my pie is broken, no!
Is it 99 or 99.5% of issues we have with the Pi Zero? They're saying my Pi Zero is dead, and it's because they just haven't imaged the SD card. It needs the latest image, it needs to be imaged correctly, and then, until then, the Pi Zero shows no signs of life whatsoever.
That was basically all of the early issues with the Pi Zero, wasn't it?
It's all the current issues with the Pi Zero.
My Pi Zero won't boot. Have you imaged the SD card for the right image? Have you put an SD card in?
Have you tried turning it off in a minute?
Have you tried turning it on?
So
So that's running away. That's imaging quite happily.
Yeah.
Yeah.
We can jump ahead and then I will get back on the writing if you guys want.
Let's do that. Yeah.
So I have a device here that basically, actually I have 3 devices here. They're running the same software. There is a Raspberry Pi 3 on each of them, and then there is a DAC with a mono amplifier and the 5 watt speaker in this case, and 2 small speakers on this one. So we have an happy phase when the device is successfully connected, and a sad scenario when the device can't connect to the internet.
So that's the red one there, is it?
Yeah. No, this one.
Right.
Yeah. So we have nothing.
So you got
displayed.
happy face, you got happy red face. Oh, it's a different colour thing. Yeah.
Yeah, I just
shake it up.
Yeah, exactly, changing colors.
Yeah.
So the software that I provisioned, that I installed on this provisioned device, has a feature that we call Resin Wi-Fi Connect, which is on our GitHub repository.
Okay.
And it allows you to basically set up a device so that if it doesn't successfully connect to a known network, exposes an hotspot with a captive portal that allows you to connect to the Wi-Fi hotspot exposed by the device and configure your credentials.
This is
and
absolutely amazing. Yeah.
Yeah, it's a cool feature, helps a lot. So I'm gonna.
It's very useful in events. We always find that going to somewhere like CamJam or BTT, we find that setting up to connect to their Wi-Fi network can be a little problematic if you're ill prepared.
So I'll connect to the Wi-Fi hotspot exposed by the device.
Cool. Let me show that big.
What happened?
There we go.
Okay.
Now you can see it.
Okay.
So you got the Boombastic Mini.
Yeah, and
Connected,
then
no internet. Fine.
I get a prompt.
Hey!
So
how did you get it to do a prompt? That's amazing.
That's
Android.
Yeah,
Okay.
It's captive. Actually, it's the captive portal.
The captive portal
It
thing.
works on iOS and Windows X.
Yeah, it's a thing. Yeah.
So then I just pick the Wi-Fi. I'm not gonna show you the password of the Pimoroni Wi-Fi.
Security.
If you take it very seriously.
And you can see here meanwhile the image is validating now. So it's written the image, it's validating. Okay.
Yeah. Yep.
And
so now the device will attempt to connect with the parameters that I set on the interface.
Oh,
hey!
Here we go.
Happy face!
So as you can see in the dashboard, we'll get back on the dashboard later, but
Yeah.
now I have all of the 3 devices online, and I can manage them, issue actions, update the software that's running on the devices. In this case, this device was running an outdated version of the software, so it's actually downloading a new Docker container. So you see that has a.
I can't show that. I'm going to need to go to manual.
yeah.
Your keyboard has failed.
There we go. You got the download arrow.
Yeah. So within your OS, we have an agent called the Resin Supervisor that exposes a RESTful API, so you can interact with the Resin features that we expose on the device.
Yep.
In this case, I wrote a Docker application that polls the status of the device managed by the supervisor, and I display an emoji based on what the device is doing. In this case, it's downloading a new container, so we have a download arrow.
Yep.
And if you can show the dashboard, you can see that the device is actually reporting its
see
state.
the progress there.
And it's downloading a new container.
So that there is equivalent to.
Yeah. So I'm using Delta downloads. So it's basically computing the delta between the previous and the latest container. It's downloading the delta, and then it will apply and restart the container
So
device.
just the differences. Yeah.
Yeah.
Which makes it really, really small.
Yeah.
Exactly.
Yeah.
Exactly.
Cool. And it'd be really fast if we weren't kind of like streaming massive amounts of video over our Wi-Fi right now.
This is true.
Yeah.
Cool. So let's see, how's your imager going?
Oh,
Right,
we're
that's
done.
finished.
Flash complete.
Flash
Okay.
complete.
So what you've got there now on that.
Yeah. So I'll remove my micro SD card.
So that is just the Resin OS. That has nothing on it. That is a blank device.
Yeah.
No,
So
we did.
when you download the Resin OS from the Resin.io dashboard, it already contains a small configuration that basically points the device to the correct application belonging to your Resin user.
Okay.
Yeah.
So when I put the SD card on the device and I power it
Probably
on,
find
Hey,
somebody's
let's see.
stolen.
Maybe I
yeah,
unplug this.
you can sacrifice the small one.
Oh, I'm sorry. And just plug it in. Which one? Anyone? This one?
Yeah.
Oh,
I see a light.
Okay.
I
it's
see
got
a
a hub on the bottom as well.
In a couple of minutes it will show up in the dashboard.
Okay.
Because it's a 0, so it takes.
So let me show you how it's how you do this because when you install the Resin operating system on the device,
Yep.
the first time you don't have any container preloaded because
Yep.
it needs to connect and then pull the first container, which is the latest available from your application.
Okay.
So you can actually configure the image that you are about to download
Yep.
straight from the dashboard, which is something
Sweet.
we forgot to do, so the device won't connect now. We need
Yep.
to repeat the process, but that's fine. It's gonna be easy. So I can actually digit here the Wi-Fi, SSID, and the passphrase,
Hey.
and I'll basically allow the device to be already configured against the network.
It's really exciting.
Yeah. So if you can hide for a second the screen,
Yeah, you
because I need to
can't
type your password.
The password's not showing there.
Okay, nice.
I've very cleverly designed the screen so
So
the
it's
password is just below the quarter.
and actually, it's blanks out the password as well when you're filling in, so it should be.
Hunter
Yeah.
22.
Yeah.
Or was it Hunter 2?
Yeah, we also have a command line interface. So if you are that kind of pirate that lives in a terminal,
Yep.
then you can do pretty much everything that we are doing here in a web interface.
Right.
You can just do it from your terminal.
Okay.
It's the entire terminal is just a
That
client.
gets me into a lot of trouble.
It gets me
I
into
installed
countless problems.
Volumio and I thought, oh, it's not connected to Wi-Fi, so I immediately started up SSH and went in and manually configured the Wi-Fi, and then it broke. So I went to the instructions and it says in very large bold text, do not manually configure the Wi-Fi, it will break.
yeah.
Yeah.
So this is about simplifying the obvious steps or the tricky, even the tricky ones, so you can only focus on the Docker application and how to deploy it.
Yeah.
So I'm basically gonna repeat the same process, but with
Okay.
proper configured
We'll skip
image.
ahead with the
Exactly.
Boombastic.
So another thing, another feature that you get out of the Resin-based development and deployment is that each device can expose an HTTP or a WebSocket service on a port 80,
Okay.
and then will allow you to publicly expose on a public URL this service on a.
But it's done in a safe way, so there's just a very narrow, safe pipe.
So,
You have the TLS encryption is HTTPS, and it goes through the Resin proxy service. But this allows you to implement stuff like remotely control your device or
So if we
exposing
wanted to redo
diagnostic.
our wall with all the letters on it,
So
Yeah.
we could use a web front end custom built. But
yeah.
So-
That way, or
Stick
for
to
example,
Twitter.
a lot of people using like Alexas, they like for their projects, and very easy to connect devices like that to your Raspberry Pi, and it's basically using like a unique ID there, so it's public, but it's not necessarily discoverable. So that's that can be your.
So what you did there is you went to the control panel
Yeah, I went to the control panel and I enabled the public URL feature.
for one of the Boombasticks.
It's the green smiley one.
Okay.
So now I can access the MoPD instance. MoPD is a MPD server that also exposes a web interface to manage your music.
Yep.
In this case, I configure it against my Google Play Music account.
Yep.
And then I can access the interface.
Someone out there on the internet is now furiously trying to type that URL.
Oh yeah. I can log it down.
Yeah, but that's okay. They can play with the MoPD. Fine.
Oh
It's all about
yeah.
for that.
Yeah.
You can actually recrawl us live if you were fast enough.
Yeah, send us some music if you're out there. And, good enough.
What they couldn't do is start trying to poke at port 22 or
No,
No.
try.
no,
Yeah.
absolutely.
No.
But they are basically completely.
Of course, I can also go local, and because the dashboard exposes the local information about the device,
That's so useful.
so I can just
So you're gonna
Do
play
this.
some music for us?
I can.
Cool.
So
This is done purely for review purposes. So.
yeah, it's gonna be a short one.
Disclaimer.
VT and Rick Astley.
Do you want?
Is that a remix?
That's
of
your
them?
specialty.
It's I mean, The cool thing about a public URL is that I can drop one of these in the office, and then when I'm not there, I can reach all the people working there remotely.
Yep.
Oh,
We have the same thing. Here we have a Pi doing Slack. In Slack you can control the music, so it's nice. Cool. Okay.
So now, as you can see, I'm streaming music directly from the device.
very very romantic pirate music.
Yeah.
And this is it.
Inconceivable.
I don't think it means what you think it means.
And now, of course, you have multiple functionalities. You can tune the software using environment variables.
Yep.
Which allows you to, for example, add secrets and sensible information on your application without hard coding this kind of information on your, directly on the application, and also tune the software behavior according to these environment variables. Like in this case, if we have time, I'll show you. I implemented a multi-room synced audio mechanism on the Boombastic.
Yeah.
Yep.
So using an environment variable, I can say the green one is the server that the broadcast the music, and all the others are clients that just reproduce the music from the server.
So it's,
The way I tune this is using environment variables.
So you see, keep the same code in all of your devices, but you can still adjust it. How do they behave?
Yeah.
There's just so many of the projects you can cut down along these lines. If you have multiple devices, they
Makes
still
them more maintainable.
Oh, very much.
Yeah.
Very much so.
Not so much magic code and having to think about things.
No, it's really
Yeah.
simple.
Cool.
And yeah, I mean, it's just about, you see.
So the music thing, that's like Sonos, isn't it? And actually getting the music syncing between rooms is actually not a trivial thing.
There's nothing really fancy that I did. It was more about setting up already existing tools.
Yep.
So the software daemon is a Mopedy, and then the way I do the synced audio is using a tool called a Snapcast.
Snapcast, okay.
So basically what happens is that the Mopedy server streams music on a FIFO stream.
Yep.
That gets read from the Snapcast server and broadcasted.
Yep.
And then the other devices, if set with an environment variable as client,
Yep.
just spawn up the Snapcast client and reproduce the music.
Okay.
So it's simple, and it still needs some tuning. So sometimes you hear a pop noise for a second, which means the devices are resynchronizing themselves.
Right.
But rather than that, it's
cool.
It's
Yeah.
cool.
And it's a good demo of what Resin does.
Yeah. And it's a good demo of pulling in cool open source projects and make the most of them, which is internally we do this as well. The big part of the platform is either using open source software or will be open sourced from our side.
Yep.
But everywhere, just like you guys release so many libraries, let's just use that, and make the most of it.
Yeah.
So
you're just going
in
to
the
burn.
meantime, I'm re-flashing our Pi 0 with the configuration.
Can we have a
And I
look
can-
inside one of these?
Oh yeah, of course. Let me grab one.
And unplug.
And I also want to show you how I deploy a Docker application.
Yeah.
Maybe we can do that for enabling the multi-room feature on the
Okay.
Boombastic.
So as you can see, he's really multitasker.
Yeah. Anyone trying to follow this on the internet? Yeah. Sorry. Our thoughts, they float about like mayflies.
Okay, so
Oh,
All the magic is revealed.
yeah. So I'm gonna do this.
so these are a bunch of layers of laser cut plywood, right?
Yep.
Exactly.
Pretty much like your Pybo hats.
Yep.
Like that was Carlo was telling me that was the inspiration original.
The pivot definitely inspired me. I mean, it's very basic compared to the how elegant is the pivot, but it's enough to keep the Pi in place with only 4 screws, and then you have the I2S digital to analog converter and the mono amplifier on this breakout, and then an I2C backpack for the LED matrix.
Yep.
And this is the 5-watt speaker.
Cool.
And yeah, that's it. It's pretty simple.
And it's got a carry handle.
Yeah.
Oh,
So that also acts as a cable holder, so you can actually make the cable go through the hole, and you don't have them
I
floating
love the way
around.
the plywood works as layers as well.
Yeah.
Yeah,
Yeah, you were saying you want to add a battery to it so you can actually carry it around?
I actually did. I have a prototype with the lithium battery, but I did a very bad mistake. So I positioned the battery here,
Oh, just behind the
just
speaker.
behind the magnet of the speaker. So I was really scared that the speaker was actually attracting the battery, and I was scared about the battery deforming because of the magnet.
Okay.
So
Yeah,
I stopped and I told myself, okay, think more about this, and then I'll try again.
Cool.
Yeah, and that's the inside of the
Yeah.
device.
Should I put it together for you?
Yeah,
Yeah.
if you want.
So, deployment.
Yeah.
You want to show a deploy.
Yeah. So this is the Boombastic software, which, by the way, is on GitHub. Is open source, both the design files and the software.
So you can laser tape one of these. Do the software on
Yeah.
it? No
Mhm.
problem.
It's here. You have instructions, bill of material, whatever is required to actually assemble one.
Yep.
And then the way you perform a push on your fleet of devices using resin is really simple. So you basically hook a resin remote to your Git repository.
Yep.
So you have the resin remote, hook it to the repository.
Yep.
And then I have a branch on my repository which is called a Snapcast, which has the multi-room features.
Okay.
So I just switch to that branch, and then I added a dash force because in the meantime I did something else on master, so I want a clean push so
Yep.
I can show you all the steps. Of course, it will ask my my passphrase for the RSA key,
Yeah.
which is hidden, so don't worry.
I've actually made it slightly worse by sharing the video there, because somebody can actually work out from your arm movements which keys click.
And
I
as
wonder
you,
if there's enough data of you typing to work out which keys are being pressed for the sound.
oh, with the old kind of smartphone dial things, you
Yeah.
could actually reverse engineer the password from the audio, the tone.
Yeah.
I mean, hopefully this is mechanical keywords as well.
So I think somebody's actually found there is difference, like a bit like the typewriter having a very particular thing on the dies.
There's the difference between the time between key presses, I think, as well, that
Mm.
made it possible to figure
Just
out
do
what
analysis.
you're typing from the sound alone.
So you should use
So what's
non-standard
happening right
layout.
now is that I defined the
People with
base
mechanical
image
keyboards are stuff.
on my Docker file, which is the way you shape up Docker applications.
Mm-hmm.
And then our builders is actually pulling the base image and adding all the instructions that I wrote on my Docker file,
Okay.
which is all that's required to control the I2C LED metrics, the MoPD server, and whatever.
Yep.
So right now what's happening is that basically the builder is executing the instructions I wrote on the Docker file. It's going to take a while because the Boombastic is really complex, so you have
Okay.
GStream, Pulsar, and ALSA, and a lot of stuff.
So from here you pushed a little bit of code to GitHub.
Yeah.
So you pushed it up to GitHub. Resin servers over here are looking at that GitHub constantly.
It's actually a plain Git, so you
Okay, sorry,
you can use
not
whatever
GitHub.
you want to actually do your configuration control, like GitHub,
Yep.
GitLab, whatever, and
Yep.
then it's only a matter of hooking the Resin Git remote to your
Okay.
existing Git
And that goes to
workspace,
Resin.
and then goes to Resin.
Okay.
So the interesting bit is that we are actually cross-compiling a Docker image for the Raspberry Pi ARM V7 architecture.
Okay.
And once it's done, it's going to be spread across all the devices that belong to my fleet.
Hmm.
Yeah, we'll show later after the build completes, but
So at some point we'd expect that to show a download thing?
yeah, exactly. Both of them, because they belong to the same application, and
Yeah.
I'm pushing against my Resin application. So
Yeah.
since they both belong to the same application, they both will start the
Yeah.
download.
While we're waiting for this,
Yeah.
we can show that
Oh.
one as well.
The portable one.
I can also show the provisioning
Okay, yeah.
thing, because we finally flashed the image. Sorry about
The
that.
image with the wireless in.
Yeah, exactly.
Mm.
So if we're lucky, this should actually just connect to the internet quite happily.
Make it visible. Yeah, there.
This time it's the right way around. Yeah.
So
So we're hoping this will come online.
So as you can see, the previous application I showed that was targeting the Raspberry Pi 3 device type.
Yep.
This one targets the Raspberry Pi device type.
Okay.
So even if it's the same code,
yeah.
I can push the same code using a feature that we call the Docker file template. So I can use a variable to define the architecture that my application targets.
Yep.
So I can push the code base against different applications, and the builder will be aware of which device I'm targeting.
Yep.
And then in this case, we are targeting the Raspberry Pi 0 or 1.
Yep.
And then in a while, of course, we chose the longest possible device because it's a little bit slow.
Yeah, it's the Pi 0.
Yeah, it's the Pi 0.
It's good. It's cheap.
Will show up. Oh yeah, I love it.
You can make a cup of coffee while you're waiting.
yeah.
Depending on the device you're targeting, you can go from an espresso shot to a cup of coffee.
Yeah. Just depends on the speed. Yeah.
And it depends on whether you typed it well, the passwords and everything.
Oh, that's a good. That's a good.
I think it's doing something.
Yeah.
Cool.
So.
Yeah.
While it's doing that, let it do that. Let's talk about some of your projects that you did. The Beast.
Yeah.
This is kind of you eating your own dog food, isn't it?
That's very much. That was a big demo project of showing how to.
Whoa. I think something appeared.
Yeah.
Oh no, we can see it appearing there. Yeah.
Yeah.
Okay.
And it shows that it's a factory build right now. So it's configuring first.
Okay.
Yeah.
Oh, this is an interesting thing. If you can show the console, yeah. So another feature that we expose is called the device configuration that allows us to define device both resin-specific or device-specific configurations. So in this case, as you can see, I enabled the delta feature, which tells the supervisor to actually compute the delta when a new update is available. But I also told the supervisor to add the device tree overlay to the config.txt of the device completely remotely. It goes, and in this case, I set this configuration application-wide. So every device that gets provisioned against this application automatically gets this configuration.
Yeah.
And you can see now that the device applied the configuration, rebooted with the new parameters, and then it's downloading the container. Yeah.
Okay. No, the container, because it hasn't got anything so far.
Yeah, exactly.
Okay, so that's going to be downloading for a while, isn't it?
Yeah.
So, the Beast.
Yeah.
The Beast, you're on version 3 now?
Version 3 being built.
Yeah. Okay.
And originally it started, I think, 120 pieces. The one that you are showing there is the 144 piece design.
Yep.
It's we were kind of thinking that how can you, if you go to an event, how can you show that you can do cool stuff with a lot of devices in the same time, just like we are trying to do here with a couple of devices, even with a pair.
Yep.
And then of course we went overboard because because that's how it's worth doing.
Yep.
And what got designed here is like a modular architecture.
Yep.
So in that image, those are 6 pies per a tile, a Beast tile. All the tiles are the same, and then you can just hook them up together here in an octo tower shape. But you can make it into a wall, or you can play around with it. That how would you like to have it? And
so, what is the base module here? Is it a set of 6?
It's a set of 6 in this version, and for a Raspberry Pi, we would like the next version to substantially level up and fill out the space. So in this blog post, we go down a little bit and kind of like maxed out a lot of our power lines and everything. If you hook up like 12 pies to single towers.
Oh, so this is going to be the version 3.
Yeah.
Which is on the works now.
Yep.
The whole philosophy is about having this the core element, which is the tile, which is going from 8 to 12 devices, if I recall correctly. And then you can basically attach more tiles to create complex structures like the one that you are showing now.
Yep.
You can go from a cube to a tower of hexagon or octagon rigs in a beautiful way.
Cool. And keep this one open source as well. So if you don't want to show pies, maybe you have a different board, then you can just take the faceplate, do a different cut, and suddenly everything is there again for you.
Cool.
So make the most of it.
Yep. Brilliant.
And The interesting thing is that this started as a cool way of showcase resin, and then we also figure out that this is actually an interesting way of trying out distributed computing. So it's also an educational project. It can be a good way of experimenting this kind of technology. So we are getting a lot of interest around that, and we are trying to make it even better with the V3, which is going to be denser, so more devices. And we're also working a lot on an easy way to daisy chain power, so each tile can actually attach to the other, and that's enough to power
passes
the whole,
through.
the whole structure.
Yeah.
That's a lot of power.
Your blog is really good. You've got lots of good blog posts.
Thanks.
Thank you.
Each of us, and the good thing is resin really lends itself very well to projects. Just like Boombastic or whatever we are showing here, and a lot more. And we love hearing about what other people are building too. It's not just that it's built with resin. That's a very tiny bit of it, but more like, wow, people are making really cool things out there. And so whenever somebody creates a cool project, just let us know, and we can put it on our blog and tell everybody and their grandmother about it.
Yeah. So in terms of what kind of pays for you having kind of paying your rent and being able to eat, that's kind of the more enterprise things. So 5 devices being managed and above, up to thousands.
Yeah.
But below 5 devices, it is free.
Yes.
So that's where you can have a very small network of, say, camera pies around your house or something, and manage them with an image. And the philosophy you say here is that you can change the code in the dashboard, or however you do, and then deploy it, and if something goes wrong, you don't lose anything.
The good thing about this setup is that since you're actually working on a container level, you still have the host with the resin supervisor connected to the resin infrastructure. So if something goes wrong, even really wrong, you can rely on this failsafe, which is I can iterate the next version of my container that addresses the issue, and I'm able to perform hotfixes or continuous integration, kind of a development on embedded device.
So you can do like, as long as there's network, you can recover, and even to the level that we are now be able to do remote host updates. So you can go and update the entire underlying system as well. So you can just go into the device as long as there's networking. You're like, oh, there's a Raspberry Pi kernel bug, like not like you ever heard about that kind of things. But let's say it happens, you can update the entire system remotely.
Cool.
In the meantime, I'm gonna set up the resin cam project. In this one, I also added more status on the LED metrics. So what you see now is a Wi-Fi emoji. That means look at your phone, you need to configure the network.
He really likes emojis, don't he?
Yeah, I mean, it's a cool way to display a feedback to the user, which is easily understandable. So I'm using the same thing that I showed you before, the Wi-Fi configuration captive portal thing. So and that's it. And on the dashboard, you'll see the usual status update with the device coming online, and hopefully a happy emoji. But this is interesting because it started like something useful to me and to anybody that was willing to use these projects. But if you think about it, the ability to have this device status information available from your application with an easy API means that you can actually implement in your application. Think about digital signage or machine-to-machine interaction. You can actually expose these kind of services in your application in an easy way without messing with the low-level Linux stuff.
We have a good question from the internet. Could the software download from another node within the cluster rather than over the internet? So can it do kind of swarming things or kind of more torrenty things?
This is not. We asked this question to ourselves, so it's definitely not the first time we. It's not a new topic. I can say that we are actually working on figuring out a way which can be addressed in several possible solutions.
Yep.
So right now, no, every device pulls the update from our cloud service.
Yep. So you've gone for kind of bandwidth heavy, maybe if you're doing a lot of devices, but reliable.
Yeah. The thing is that you
get the more efficient.
Yeah. I mean, if you enable Delta, and we also have in the documentation, and I think that there is even a blog post about it. We explain ways of reducing the bandwidth usage on Resin to the level that gets really low, especially if you iterate software, so the delta is between a container and the other is small.
Yep.
So we get to the point that is actually reasonable, but this doesn't mean that we are not working on other approaches.
So there could be swarming, but not now. But like you say, you already do deltas, which are a fraction of the size of the whole image. Yeah. Okay.
We also expose Alpine-based images that are really, really small. Alpine Linux is a very tiny Linux distribution that you can use as your base image in your Docker application, and that reduces a lot the footprint of your whole Docker image.
Yeah, and updates very quicker.
Yeah,
a lot quicker. And
you also said as well, if you're doing if you want to test deployments on a subset of devices, you can kind of split.
Yeah,
you can have
So you could, for example, you could go around it. You create an application for your testing devices, and you create another one for your production devices, and you can easily move device between. So maybe you have one Boombastic that is on my production level. You're working on that one, and you just in one click you can move it over, just like Carlo is showing in the screen. In one click you can move it to another application that may be completely different. Maybe it's switching from Raspbian to Alpine. Maybe it's changing from being a speaker to an instant rickroll. You just add the button and it's done, and it just deploys that application right away. Once you are happy with what you see, just move the devices over, and then you push to the other application. That would be the easiest at the moment, but there's more nuances to it. And what we see a lot of people asking this feature, but all of them are asking it a slightly different way. If that's familiar to you, everybody's using the same code, but different details.
That sounds good. Yeah.
Okay, in the meantime, it's hidden from our faces, but we actually got what we call the unicorn, which means that your Resin push succeeded. Here's the unicorn.
So I can't quite see that, can you?
It's
dark blue.
Dark.
Okay. I hope that you guys are see that, but
you have to find yourself.
Yeah, exactly. It's a matter of successfully pushing an application to Resin. But basically, this means that our device is downloading the Delta. So, as you can see here, the device is downloading the Delta. So right now we are really hogging your network. We have this device downloading, this device downloading, and you can see the progress of all your devices. This is several different applications, several different devices running different code being updated simultaneously, and I can track all of them. So in this case, you see that this device is completing the download.
Hats.
You really do.
So you put a different hat on your Pi, move it over to a different application. It's gone from a unicorn hat to a speaker hat, whatever. Cool. Right.
I really like this setup up here. Some guys on the forum who currently talk about archery target boss monitoring. So your archery target is so far away you can't necessarily see whether or not you've hit it or where you've hit it. So they're talking about mounting cameras below the target.
I use the common lenses that you can attach with magnets to the smartphones. So they usually come in three sizes, which is the fisheye, the tele lens, and so you can easily use the one that fits best your
this is quite good for someone who's a beginner and just looking to get maybe four
we could totally
cameras
steal that
up and running.
like for a Pi OLED.
Absolutely.
You've probably open sourced it already, haven't you?
Yeah, it is. It's called the Resin-Cam, and it's on the Resin Playground.
So we can make some, but we just have to make sure people can see the source.
So I can show you a hint. I'm working on simplifying the whole Resin-Cam thing to an actual P-ball layer.
Okay.
So
let's do that.
Yeah. So
and then open source it.
Yeah, exactly. It will be easier to source and it also will expose ports because I got lazy, so I just basically wrapped the whole design.
It is hard to expose.
So with a proper PIBO, you know also expose ports, which is nice.
Yeah, some people don't want to though. So
this is exactly what you want in an archery target. It's sealed. It's even you could quite easily wrap that around to make it weather sealed as well. All they need to do is sit 4 of them in the field,
just get some,
connect them to a Wi-Fi hotspot or to a laptop, and then just stream the video feeds back. And you don't have to worry about the software.
Yeah.
Get some anti-hydration gel, silica gel in there, just to keep it nice and
seal it up good.
And probably run some machine learning or image recognition, and then automate the whole. Like, did I hit the boss?
Oh, we can have like the big matrix displays. You can have a whole line of those across
we
the
have
top
a
of the
colleague
target.
that is working.
Yeah.
As a Friday hack, we have a colleague, Cameron. Hey, Cameron. Hope you're watching us. Yeah, that is actually working on big LED matrices.
So you can have the accelerometer, so it knows when something's hit the target. You can do OpenCV to work out where the arrow is, and then have a big sign above
The
that says,
downside of putting
"You suck."
LED displays above the target is
You're gonna
the
hit
problem
the-
with hitting them.
Well, then you just buy a new set.
Polycarbonate, it'll take care of everything.
You'll be surprised.
Yeah,
I had a friend who was into archery who was playing with the bow and arrow in his garden, which he should not have been doing under any circumstances. And it shot through the target and through his back fence and into the neighbour's garden.
Yeah, you're supposed to make sure it doesn't leave your property, I think. Yeah.
Not.
And apparently not within 50 metres of the centre of any highway in the UK.
Yeah,
That's the
imagine
rule.
not. I noticed they do it in Ely. If you look out from where the train station is in Ely, there's a field back there where they do archery practice, and they're obviously facing away from anything, just towards miles and miles of empty fields and nothing.
James Mitchell is on the internet saying 0360. Oh my! I need to look at this. So he's got 8 Pi Zeros doing panoramic cameras. And I think updating the software is probably a little bit too taxing at the moment for him.
Yeah.
So he's suddenly thinking, Resin IO.
Oh yeah,
So
and
360 is really cool as well if you haven't seen it.
No, I haven't.
Style.
Have you?
do you want to point James on our GitHub channel or your forum? I mean,
Sure.
James, if you want to share, your experience with Resin and ask.
Let's talk. Forums.resin.io.
Yeah, James is great. He runs the Raspberry Jam Berlin.
Cool.
Yeah, he's just been a great guy.
Yeah. We just had as you mentioned in the beginning, we are a distributed team. We just had a new
Show
team member.
Show the back of your hoodie. We can see the back of the hoodie.
If I can turn around.
So this is from the last time you all met up.
Yeah.
In November.
Yeah.
So since we are a distributed team, we do this Resin Summit once a year, which basically means that all the people gather together. Last time it happened in Athens.
Yeah.
And for 2 weeks we work together and we talk about future strategy and it's a really great chance to actually keep in touch with all the people that for the rest of the year you just digitally interact with.
Yeah.
There's yellow dots where in the world you are, and they're all over the globe.
Yeah, I think that this is already updated. By the way, we have more dots now. We cover.
Just get a marker pen and fix that.
You have like 30 plus people, don't you?
50 now.
50.
50 now, and
that's okay. That's good.
And we have one new person in Berlin, so I hopefully can meet up. Or
this summer we'll be in Berlin. So Make Fair Berlin, good Make Fair. You should totally go there. You should meet James. He's in Berlin. Yeah. So we'll do Berlin. We'll do beer. There'll be food. It's a good time. Yeah. Cool. Nice. Yeah. How are we doing on the download? The download is 71%.
So we are
down 39%.
39 on the big one. Yeah. And.
I don't think we're going to have time to watch it all, but trust us, it works. This is by far our most successful live demo ever, which I think is great credit to your software.
I'm always asked about, do you really think comfortable doing live demos like that? I mean, this is what we do as a business, so we are really comfortable.
You're paying the dividends for kind of honing your software and the images and the tools.
The downside is that it takes time because it's happening for real, but definitely.
Yeah, but that's a big image.
Yeah,
it takes as long to download as it takes.
We actually have the builder now. This is a feature that we released recently. Tells us the size of the Docker image. So it's 660 megs
times 2.
Yeah,
that you're downloading while we're doing live HD video.
Only this one is downloading the full image because this one already had a version.
Yeah,
you just have to update. So that one is probably doing better. It just started later.
Yeah. And also I think we are a little bit in overflow on the
Do you want to see?
Yeah.
He's asking what happens if if you are unplugging now.
Do that.
Well, one, it is turned off.
Yep.
Check. The second one soon it should realize that that it didn't quite.
So we do some actual computing on these state changes. So we wait a little bit to be sure that it's not just a network spike.
Yep.
So it can take up to a couple of minutes to update only the offline state.
Yep.
Like
Because when the device goes online, it connects to our infrastructure, so we are sure that that's a proper state change.
Yep.
When it goes offline, we wait a little bit, a couple of minutes, and you'll see the device going offline. Nothing happens. You can't, the container download will, execute it again next time we power up the device, and that's it.
Cool. Yeah. So I think anybody who's watching this now has an idea of what the power of this is. Even just on a very simple level, it's just kind of immensely cool and useful.
Yeah, and the interesting thing is that even if you're just prototyping, it allows you to, once you get the proper setup, you're already in the situation of replicating the setup on multiple devices, or even going to a different stage of selling the device or spreading with the community your project.
Did you say there's something where people can publish their images?
We're planning something around that. So there are a lot of open source projects that for example, you finished a Boombastic like this. You open up the code and you could just deploy the way it is. You didn't have to change anything. You want to make this step such that you don't have to worry about setting up your Git credentials or anything. You can just click a button that I want Boombastic on these devices because I already set up the hardware. That is not there yet, but we are working towards it. So if you have any thoughts on it, how it should be, because for example you guys have a lot of projects as well, and out there the community has a lot of projects that are more and more polished each day.
People just want the canonical CCTV Pi thing. The canonical Bluetooth
speaker.
Whatever speaker.
I
just want the best one, and then they can.
Personally, I want a dozen of these. But, okay, maybe 3.
I'm actually working on a couple of new features for the Boombastic. The first one is the Bluetooth streaming audio,
Sweet.
Which is going to be an intense one because it's a really complex stack to implement. I've seen a bunch of guys already achieving this kind of functionality on the Pi before. So maybe I
certainly had one set up as a Bluetooth speaker. It was very finicky about which version of Blues I was using.
It also comes down to how easy it is to pair your smartphone to the device. Because a lot of projects I've seen require you to SSH into the device and allow the MAC address of your smartphone on this kind of stuff. While I'm aiming on a consumer-like product that you can just connect from the phone and start streaming.
You don't have those problems. So is the device offline yet?
Let me see. Should be.
Yay! Cool.
Yeah, it is.
It works. Best demo ever.
So the cool thing is that you keep your logs. So if something goes wrong and the device goes offline, you know what happened. This is persistent. Next time the device will be powered up and connected to the internet, it will
receive the download.
It starts from the beginning, but with the deltas we are working on, resumable deltas to even save more.
So if you're not, this is some bad deltas are about to be are still being worked. This is why it's not default.
You want to get those bulletproof.
Yeah, exactly. So before making an option default, we need to be sure that it's actually bulletproof. So right now it requires you to specify to the supervisor, I want to use deltas. As soon as we nail these, last little bits, it will probably, I assume, become default. So right now, if you don't use delta, it resumes the download. If you use delta,
like Docker itself is trying to be smart about it as well. So which is already a good place to start from. So we love all the things that it's already come with. We just try to improve on it on the specific use cases.
Cool. Right. I think that'll do us for today. That's been a good in-depth demo and look at an exciting set of toys. I'm sure you'll hear more about this. Cool. Right. So we'll see you next week. I think we're planning Thursday as normal. We had a special this week for the Me Arm Pi, which again, talk to Ben, I'm sure he'll love a deployable image for the Me Arms that he's now selling a lot of on Kickstarter.
Oh, cool.
Oh, interesting.
I think they're looking for...
Funded on the first day, wasn't it?
Yeah, it took
Wow.
about 8
Straight out
hours
the
to
gate.
fund on the first day. Got them past 10 grand and they're now on about 25 grand.
Oh.
So they were on Forbes, they're on the front of the Raspberry Pi thing, and Ben's been a maker forever, and him and another Ben have joined up and now have this beautiful kind of honed laser cut arm robot empire
Ooh.
going on.
Nice.
So
Uh,
you had me at robots.
Yeah. Well, what they want to do is they want to get 6 of these robots with 6 pies, invert them and use them as legs for an
Nice.
export.
Yeah.
So
That-
Docker would be...
Oh yeah.
That
Resin.
escalated quickly.
But
Yeah.
I like the idea. You actually triggered me.
yeah.
Oh no! Now he's gonna work on all these for the next foreseeable Friday hacks.
And
Yeah.
of course, I'll make it work remotely on the London office, so I can follow
Around,
people.
yeah.
Yeah.
You
And
have a
the-
little Pi TFT and
and
a
the-
camera so you can be telepresence.
And our office door is
I'm
actually
watching
tied into our API, so the robot might come, open the door, and
Yeah.
come visit us.
You can't keep it out.
Look what you did.
Yeah. This is how it happens. This is how the machine overthrow happens.
Yeah.
All right. Thank you very much for travelling up here. It's been an
Yeah.
absolute pleasure.
It's
Yeah.
been an honor.
Indeed.
Thanks
know-
a lot for hosting us.
When things kind of get along and you have new features and you think it's right, come back and talk to us again
Oh.
about this.
And we're gonna have a hackathon in London in
Okay.
March.
So it's March
11.
March 11th in London.
It's
There
a
is
Saturday.
a resin hackathon.
Yeah, it's
Cool.
focusing on hardware. So we actually stocked up from you guys quite a bit.
Okay, brilliant.
So
Yeah.
looking forward to what we build, and we share it with you.
So hopefully, kind of a couple of us will be able to make it down and just kind of sit with you on that, because that sounds like a fun
Oh.
day.
Yeah.
Yeah.
Should be.
Cool. Right. Thank you for tuning in, folks. See you next week. Don't
Thanks,
forget to
everybody.
like,
Come on, man.
subscribe.
Subscribe.
Bye.
Bye.